Okay, so last night I sent out an offer to every one of you, but it's only optional. So basically, this Friday, 10 a.m. to 12 noon. So because you have your programming test next Tuesday, right? I'm just worried that maybe some of you might still not be so comfortable with Java programming. That's why I'm offering this, right? So this is completely optional. I'm going to confirm the location with you later. But Friday, 10 a.m. to 12 noon, I'll try to do a little bit of Eclipse and Java programming with you. If you find yourself comfortable with Java, you don't need to come. All right? I'll confirm that with you, the location, later tonight or tomorrow. All right, let's talk about the subject today. So we introduced the idea about equality, especially equals method. Okay? All right. Remember, this particular diagram here is really important for you to have in mind. Every time you talk, okay, so we know that we have an object class which got the default version of the equals method. And then whenever you're trying to define your own classes, you have two options. Either you simply don't explicitly redefine the equals method, in which case you'll simply reuse this default version. Otherwise, if you try to redefine your own version over there, and for that particular version, we have certain ways for you to actually write it, right? We explained each one of them last time in details. Okay, assume you're okay with that. Okay, review the lecture notes if you got trouble. Well, speak to me. Okay, so we got these two cases. Today, we basically go a little bit further. First of all, we try to see how you can use JUnits to test the equality between objects, number one. And number two, we try to give you a little bit more complicated scenario to define the equals method. Specifically, for example, how do you define the equals method for point collector? Where you have an array of objects. How do you do that, right? That's something we'll get into later today. Let's do the easier one first. Okay, so now this is, let me just show you the slide I'm referring to. So this is kind of the slide we left off from last time. Basically, I simply said, if you try the assert same over here, you're simply comparing the addresses between the two objects, right? That's easy, okay? And then we talk about assert equals. So now you got to think about three different scenarios. Scenario number one, if expression one and expression two, they're simply just primitive types, like an integer, Boolean, character, etc. In that case, you just use compare their values. It's as if you said expression 1 equals expression 2, right? That one's easy. Now, the other two cases is a little bit trickier, but it definitely can correspond to this particular diagram I talk about. Either you have the either you don't have the equals method overridden in your class, or you have it. Okay, either case. So now let's talk about the two cases. And then I'll give you a little bit taste about what you can write, and then we'll explain each one of them in details. So now we got assert equals. The principle is, if expression 1 and expression 2, they're simply reference type, which means their type come from certain classes that you define. Okay? In that case, you got two cases. Okay? But in both cases, you can think about it's as if you try to do expression 1 dot equals expression 2. Now I repeat. It's really important for you to see this. Let me use a separate slide to show you. Okay? Every time, if you say assert equals, okay? If I say object 1, okay, I'll just say objects, different variable or expression. Object 1, object 2. Versus if I have assert equals over here, object 2, object 1. These two mean something different, okay? Well, how are they different? I'll tell you right away, okay? This one here is saying object 1 dot equals object 2, which means object 1 over here is the context object under the hood. Okay, can you make a logical guess? What should be the second one? Object 2 that equals object 1, right? Everything is logical, right? Nothing is arbitrary, okay? Now over here, this would be the context objects. And then I can say object 2 dot equals object 1. So number one, I want you to remember, okay? The first one is just going to be the context object. So when you say object 1, object 2 versus object 2, object 1, they mean something slightly different. Here's the principle. If object 1 and object 2, they are exactly the same type, it doesn't really matter, the order. However, if they are different types, things get a little bit trickier. But I'll get there when we get to examples. Okay? Any question up to now? Kind of follow what I'm trying to say here, right? All right. Let's keep this in mind, and then let's go a little bit further with the examples over here. So now we got case number 1. If expression 1 and expression 2, basically specifically expression 1, okay, the context objects. If the equals method was not explicitly defined for this class over here, then it will be as if you try to say compare the addresses, right? Just call the default version of the equals. And then case number 2, I'll go over the example with you in just a moment, okay? How about what we're doing now? Okay, so now only worry about case number 1 over here, only case number 1, okay? And then we'll worry about case number 2, which is slightly more complicated, slightly. So now I want you to think about here, we got P1, P2, and P3, right? Okay? Notice that P1 and P2, they are of the same type. However, P3 is of a different type because we're using version 2. And recall that we only got equals method redefined in V2, right? That's what we said last time. So now we want to know the following, okay? Let's compare the two things over here. Number 1, we say assert equals P1, P2. And then we say assert equals P2, P3. Okay? You want to take a guess? First of all, what about the first one? Would it be true or false? False. Why is that?
Because the context object in the first one is P1, and P1 has a default .equals.
Exactly right. Okay. Context object is P1, and then its class is simply point V1 does not have equals redefined. Exactly. So this one here is simply the same as P1 equals P2. Okay, that's good, very good. And what about the second one? Second one, true or false? Second one is a little bit bizarre, right? Somehow we are basically calling, okay, how about putting it this way? Context object, we know P2, agree? And then it would be as if we say P2 dot equals P3, first of all. However, now the types for P2 is V1. The types for P3 over here is V2. They are different types. Is the equals method redefined in V1? It was not. So which version are we calling? The default version. That will simply be boiled down into P2 equals P3. Okay? This one simply means, are their addresses the same? Cannot be the same, right? Because P2 and P3, they're simply different new objects. So it will just be false. Okay? Following so far? Okay, but I do want to explain something a bit interesting in Java. Okay? Both of them are false, but for different reason. Okay, for the first one, it's simply different V1 objects. For the second one, they are simply just different objects of different types. Okay, so now I want to show you something very interesting in Java. Okay, in Eclipse specifically. Let's say the following: if I say point V1, P1 is let's say new something. Okay, and also we have point V1. Also V1. P2 is new something. And then I got one more, let's say V2, okay? P3 is also new. Okay, I'm gonna write several expressions over here. All I want to know is, should they compile or not? That's all I want to know, okay? Just bear with me. Let's say number 1 over here, P1 equals P2. Number 2, P1 dot equals P2. Number 3, P2 equals P3. Number 4, P2 dot, sorry, I'm running out of space. Beg your pardon. P2 dot equals P3. Okay, 1, 2, 3, 4. How many of them does not compile? Oh, I'm only talking about compilation. Let's try one by one. How about that? The first one, should it compile? Okay, why does it compile? Same type, exactly. P1 is of this type, and P2 is of the same type. So in order to compare addresses, you got to compare apple with apple. Okay? Compiles, because same type. Very good. And now, number 2, should it compile? It also compile for the following reason. Because over here, P1 over here is simply just a reference type. Every reference type you can call the equals method, every one of them, doesn't matter. And then P2 over here, even though, okay, sorry, let me say it this way. P2 over here, remember for the equals method, we simply say objects and then obj, right? Okay, equals method, just to remind you about the signature. That means any object will be okay. In this case, P2, the type is simply point v1, which is an object, so that's also fine. Okay, so far so good? Now what about number 3? Would it compile? It wouldn't compile, simply because every time you want to compare addresses directly, it should be address for apple versus address for apple. So now, because P2 and P3, they're of different types, so it's not going to compile. Okay, let's write it down. Not compile, simply because different types. However, what about number 4? It compiles. That's the funny part. Number 4 compiles for the same reason as number 2. Number 4 compiles simply because, number 1, P2 is a reference type. So every reference type has the equals method. And also P3 over here, every reference type is an object. So that will also be fine. Okay? However, the way to think about how line number 4 is going to be executed, I'll put it here. Number 4, okay, at the runtime, it is going to compare P2 equals P3. So the idea is you cannot really write P2 equals P3 yourself directly on Eclipse. However, under the hood, when you say P2 dot equals P3, this is what they do. You cannot do it by yourself. How about that? It's only the privilege for Eclipse at the runtime. You cannot do it. I cannot do it either. Only at the runtime where you call P2 dot equals P3, because we know that he's going to use the default version of equals. So they will do P2 equals P3. But you cannot write it explicitly. That's something I want to mention to you. Okay. Guys, any questions up to now? The 4 cases, right? Okay, hopefully they're not too bad. Alrighty, after this, let's go back a little bit. Okay, so now we are ready to do case number 2. Okay, so now for case number 2, again, we got P1, P2, P3, right? P1 and P2 are the same type, but P3 is a different type. Let's try the first one. What about assert equals P1, P2? Should that be true? Actually, I already got false over here, right? Okay, I should have covered that. Okay. Why would that be false, though? Why would that be false? That's an important question. Number 1, which version of the equals method are we calling? Default version or overriding version? Default. Simply because, let me explain again. I'm pretty sure you know, but let me trouble you again. It's because P1 is point v1 has default version. Okay, that is why it is just going to be false. Okay, when you look at your slide, you will see the answer. Okay, now what about the second one? Assert equals P through P2, P3. The answer is going to fail, but why does it fail? Okay, oh, are you sure? Okay, this one, let's discuss that quickly, okay? If I think about this one over here, which one is a context object? P2, right? So this is equivalent to P2 dot equals P3. All right, everybody agree? And now P2 is of type V1. So which version are we calling? Default version. Since we call it default version, it boils down into P2 equals P3. You cannot write it directly, but that's what's going to be executed, as we just explained. Okay, so that's why it will fail. They're simply different addresses of different types. Okay, finally, what about this guy here? Assert equals P3, P2. See, yeah, I'm not trying to trick you. That just happened, right? You might say P2, P3, P3, P2. It's also failing, but for what reason? Right? So what I will do is, sorry, I'm running out of space. I'll put it here at the top, okay? So now when you say assert equals, and then I say P3, P2, let's be very logical here. It's simply equivalent to P3 dot equals P2, where P3 is the context objects. So now, which version of the equals method do we call? Customize, right? Because P3 over here is of type V2, where we got an overriding version, right? So now this will be calling the overridden version. Okay, good. However, if you call the overriding version, right? So now P2 and P3, are they of the same type? No, let's keep that in mind. And then I'm going to switch a little bit. Not the same type. If they are not the same type, I'll let you cheat. If I go back to this definition here, if P2 and P3, they are not the same type. So now at the moment, the context object is simply just P2. So that means this over here is simply just P2. And OBJ is simply P3, right? P2 and P3. So now, which one is going to fail? Which one are we going to, exactly that, right? That line, right? Hopefully you see that. Over here, what's going to happen is P2.getClass is going to give to me, oh, you're right. Yeah, thank you. Yes, P3, P2. Yes, absolutely. Thank you. I appreciate that. So now let me put this to be P3, and that's P2. OK. So that'll be P3, and that will be P2. OK. All the previous two checks will simply fail. I mean, the condition will evaluate to false, simply because this equals OBJ. P2 and P3, they're different objects. So this will evaluate to false. And also, the P2, the other one, is also not null. Okay, so that will also evaluate to false. So now, if you say P3 dot get class not equal to P2 dot get class, is that going to give us true or false? True, right? Because P3 dot get class is going to give us the V2 class, right? So that one is going to give us point V2. On the other hand, P2.getClass, and remember P2 is of type V1, right? And this will give us point V1. And these two not being equal should be true. If it is true, that means we're going to return false. So that's why the assertion failed. Okay? The last case is the trickiest one. Okay? Let me summarize the last case in case and then you can ask me a question. The last case over here, I really want you to pay 100% attention to this. It really illustrates many things. Number one, we know that the context object is going to be P3. And then we know for P3 being the context objects, the type is simply just point V2, which has the customized version. So we're going to call it customized version. And now it's even more important for you to realize why P3 that equals P2 will actually return false. You should know it's exactly this line over here that trigger the return value false. Okay? When you study about this example, that's what you should know. Okay. Got it? Guys, are we okay? Okay, not too bad, right? Okay. All right. that's about it. If you understand so far, that'll be pretty good. Okay, let's go a little bit further. Okay, basically what's left will be some very quick affirmation, reinforcement of what we have seen. Okay, so now let's see different JUnit test cases. Okay, you're gonna see assert equal, assert false, etc. Okay, so now let's see very quickly. So maybe for your second lab test, written test, that's something I can ask you about, right? Second one, don't worry, it's not happening soon, not that soon. But the second lab test, I can tell you, that one there, I plan to ask you lots of questions about inheritance. That's actually even more important, right? But we'll get there, don't worry. Okay, so let's look at the test quickly over here, okay? So now, let's just try the expression very quickly ourselves, okay? So now we're creating P1 and P2, okay? We got P1 and we got P2 over here. And then they're of type V1, the version number 1. Okay, so P1 should be 3 and 4, and also here should be 3 and 4. So I'm pretty sure every one of you is very comfortable with the diagram, right? I'm pretty sure. Okay. So now, question number 1, P1 equals P2 should be trivial, should be false, right? Different objects. And then since we are trying to assert false, so it will be a pass. Okay? Next one. If you try to say assert false, and now P2 equals P1, will just be false, right? And false is exactly what we are searching for, so that'll be okay. All right? So now let's try this one here. What about when we say P1 that equals P2? Okay? The only thing I want to ask you about is which version are we calling equals method? Default or customized? Default, right? How do you judge again? P1 over here is of type .v1. So that's the first version, which has not overridden the version, okay? So just default. And this simply boils down into P1 equals P2. As we said, is simply false, right? Similarly, also when you try to do this, the context object is P2. So now, are we calling the default version again? We are, right? Because P2 over here is also of type .v1, right? The same version, also default. Okay, so this boils down into P2 equals P1. Okay, that's as far as this example is concerned. Okay? This one's very easy. Okay, any questions? Okay, all right. Let's switch to the next one. The next one there, we only try to test the overridden version. Okay, so now let me put it down. So now we got V2 version over here. So we got 3.4 and 3.4. Okay, I'll put 3.4 here and 3.4 here. Okay, so now similar logic. P3 the same as P4, address-wise, false, right? Assert false will give us a pass. Similarly, P4 and P3 refer to the same objects, definitely false. Assert false will give us pass. Okay, similar logic. Now I want you to look at what about P3 that equals P4. Okay, which version are we calling? Default, overridden? Overridden, thank you. Okay, I'll write it down for your reference. It's going to call the overridden version. Simply because the context object P3 is declared of type V2. Okay, and then this will simply boil down into P3.x equals P4.x, and also P3.y equals P4.y. By the way, P4 is simply of the same type, right? So that's why we will go into that particular cast. Okay? So that will simply just be true. And similarly, I will leave this to you, right? P4 that equals P3. Because in this case, P4 and P3, they are of the same type. Both the version 2. So you'll call the same overridden version. All right? Now, finally, third version. Now we try to mix them. Okay? But everything has been said. Let's try this. Okay, let's not worry about the comments over here. I'll go over that in just at the end. Okay, I want you to look at here. We got P1 over here. We got P2 over here. Notice that they are of different types. The one is V1. The other one is version 2. Okay, so now first of all, I will fill in 3.4 and 3.4. Okay, 3.4 and 3.4. So now let me write it down. Let's try this. If I say P1 dot equals P2, which version? Default, right? Thank you. Okay, default version. Okay, because you can see P1 over here is simply declared to be version 1. Okay, so now, so that means boil down into P1 equals P2. Okay, however, if you write P1 equals P2 directly yourself, would it compile? No, it wouldn't, because they are different types. However, under the hood, that's exactly what they do, but they have the privilege to do so, not you, not me. Okay, okay, let's do the last one. Okay, so now let's try this. The last one over here, P2 dot equals P1. So P2 dot equals P1 over here. Okay, so now context object is P2, which is of type version 2, right? So now it should be able to tell that should be the overridden version, okay? I agree with you. However, can you tell me, since we're calling the overridden version of the equals, right? In this case, P2 dot equals P1 is going to give us true or false. False, which line? Is it from this line? Or is it from this line? Or is it from this line? 1, 2, or 3? 2. Very good, right? Because over here, if you simply check the types for the two objects over here, so this will simply just be P2, and obj will just be P1. Their class will simply be different, right? So return false. Okay? It's just reinforcing. We talked about this already. All right. Finally, I want to make a very quick remark to you. Okay? Let's have a look at the one in orange. So now, if you simply say, I want to make sure assert false, P1 equals P2, okay? This one should not compile, right? Because that means I'm writing out P1 equals P2 directly. So this one is not going to compile, simply because P1 and P2, they are of different types, okay? So, and this one as well, okay? So these two, okay, I'll make a note here, not compiling. Because P1 and P2, different types. Okay, on the other hand, if you try the following, you say assert the same, and then you simply say P1, P2, P2, P1. What they will boil down into is, I'll just do one of them. Let's say for the first one here, okay, the first one. The first one will simply be P1 equals P2, but it is not something you write directly. It's something that will be executed under the hood, right? So this one is going to be evaluate to false, but it will compile, okay? It's going to compile and then evaluate to false, okay? Because they're different objects. Yeah, these are the kind of tricky things you have to watch for, right? Yes? You want to say it again, please.
If I want to compare, like, if I want point P1 compared to point P2 to equal to true because they have the same values inside of them.
Yeah, okay, sure. Programmatically, you definitely can do. I'll show you anyway, okay? However, okay, let me show you. The question was, what if you really want to compare these two objects? What if, right? Okay, I'll show you. I'll give you a little bit idea. Okay, so now let me just make the points clear. If I got point V1, P1, new point V1, 3, 4, for example, okay? Point V2, P2. And then also 3, 4. What we know pretty well, I'll put it here. If you simply say P1 dot equals P2, it's going to give you false because they're different types. Similarly, if you say P2 dot, P1 dot equals to P2 will just be false because different references, okay? On the other hand, if you say P2 dot equals P1, it's not going to call the customized version, which will also give you false because there are different types. Okay? That's what we know from the previous slides. So now, how can we compare them? You will have to write some specialized version of your methods, right? I would suggest maybe you can do the following, okay? Maybe you can simply do, let me just put another page, okay? Let me just copy the, what you can do is like this. You can have a method, let's call that compare v1, v2, for example, okay? And then over here, in the parameter, I'm going to specify what the types are. I can say point v1, let's say p1, and also points v2, and then p2. Okay, let's say it returns a Boolean. And in this kind of specialized method, I can now actually specify how I can compare them. I can simply say return, because now for p1, it's declared to be point v1, so we know that x and y should be there, right? So I can say p1.x, and also p2 is of type point v2, so x should be there as well. p1.x equals p2.x, and also p1.y equals p2.y. Okay, that's how you can do it. Okay, basically you just want to set aside some special method. However, the question is, why would you want to do it, right? Usually, when you have different classes, that simply means there are different types of entities. So you wouldn't really want to compare them with each other. You wouldn't want to, unless you have inheritance. But that's something we'll talk about after reading week. Programmatically, you can definitely compare two objects of completely different types. That's not a problem. However, the deeper thought is, why would you want to do it, right? They're simply different kinds of objects. You shouldn't compare them. Okay, so now I believe the next part will be to do something a little bit more complicated for the equals, right? Let's learn something a little bit difficult, a little bit more difficult. Okay, we talked about this example here thoroughly, and also we talked about this JUnit test. Okay, we went over them about different situations. So now let's try. Okay, so now let's say we want to define the equals method for the person class. Okay. Let's say the person has name, weights, and heights. Okay, string name, double weights, double heights, let's say, or integer, doesn't matter. Okay, they got 3 attributes. So now, how can we override or redefine the equals method in person class so that we can compare two person objects by using their contents rather than references, right? Of course, you gotta follow the very big formats. Okay. Let's see. I'll go over this with you. Okay, let's say we got first name. We got first name, we got last name, we got weights, and we got heights, right? These are the attributes. So now, how can we define that? Okay, of course, you got to declare the equals method first of all. Okay, that means I'm overriding it. And then the first line always the same, right? If the reference is the same, return true. Okay, second one. So now, question for you, right? You can see this version over here is slightly different from the version I presented before, right? What I did previously, let me remind you, okay, over here. Oh, you know what? Let me show you how I got it. Basically, what I have is over here. So this is the version I had previously. Okay, just use the version 2 example. Okay, basically what I'm doing is this. You can see that over here. This case, if this is the case, I'm going to return false. And also, if this is the case, I also return false. So that means if either the case is the case, then I return false. Why can I not combine the conditions together? Right? If I want to combine the conditions together, should I use conjunction or disjunction? And or? Or, right? We want to say either it's because this condition here, or it's because this condition here is true. Both cases, either case, I'm going to return false. So what you will see over there, combine these two to be if obj equals null, or, and then I'll say this dot get class not equal to obj dot get class. Okay, and then I will say return false. So this is completely equivalent to the previous version, right? I'm just showing you some variants over here. Okay. Everybody comfortable with the variant here? Okay. That one's not too bad. Okay. So now, and then from this line here, you can see we try to do the cast. So now we cast the obj, which is objects, into person. Okay. And then we simply try to do 9, 10, 11. We're saying that the two persons will be considered as equal if their weights the same, heights the same, and also their first name and last name are the same. And what's the type of first name and last name? String. Okay? So I have a question for you. Okay? Question here. I'll switch to iPad, and then I will ask you the question. Question number 1. Line number 10, line number 11. We are calling equals over here, right? Which version of the equals are we calling? Are we calling the object version, default version equals, or we are calling something else? Yeah, hold it. Huh? Yes, somebody?
The string version.
The string version? How did you know it should be the string version?
Because the first name is the string.
Yeah, that's exactly right. That's how you derive. Okay. Idea is, if you want to figure out which version of the equals is being called, look at the context objects. In this case, this is a context object, right? And this is a context object. And then, as you said, if you look at the context object over here, first name and last name, they were declared to be string. And the string class actually overrides the string, this equals method. Okay? That's a question number 1. Okay? It's really important. Yes?
Even if the string class does not override, let's just say hypothetically string class does not
Hypothetically, let's say they didn't. Let's say.
Right, so we would have a default equals method then.
Yes, correct.
But, so when you declare first name, it would be a string literal, right?
Mm-hmm.
So
Oh, I see what you mean.
String is created and then
Yeah.
points to the same
Yeah.
object. And
What-
the address would be the same.
What you're saying is absolutely true, but I wouldn't want to discuss this in the class. That will get everybody a little bit more confused, because talking about string literal versus string objects, I would say that's a very tricky part of the Java. That's not very logical, just happened to be the case. I would say I wouldn't worry too much about it. Okay? Okay, guys, let me just, for question 1, basically, you have to understand the following. Okay? Every time, because now you know how to redefine the equals method. So it's going to be a very popular question for me to say, every time you see the equals method being called, always think about which version is being called, right? In order to judge, look at the context object over here, and then see what's the type of the context objects. And the type should tell you whether it's redefined or not. Okay? Okay, now, question number 2 for you. Okay? Look at line number 5, please. Line number 5. Here's the question. Let's say somehow we say, let's say P1 is a person, let's say, okay? P1 is a person, and there was a P1 dot equals, and then I simply pass null. Okay? Now, in this orange case over here, are we going to have a null pointer exception? Let me make it even clearer, the question. Okay? I want you to think about it. Okay? Let's say this. At the run, let's say we're trying to make the following call. We say P1, which is a person, okay, dot equals null. That means the obj is now null, right? The obj over here is null. That means obj over here is null. All right? And obj over here is also null. At the runtime, when we try to evaluate line number 5, are we going to get null pointer exception?
So we're going to get that exception as long as P1 is null, because we're calling the method equals P1, right?
Yeah, so P1 is guaranteed. So for this discussion here, we assume P1 is not null. We assume.
It should have null pointer.
Why should it not? Because you see, over here, the null over here is the argument, right? This is null. So that means every occurrence of obj should be replaced by null. So that means this should be null, and this should be null. Why wouldn't get a null pointer exception here? Why would I not get a null pointer exception over there? Short circuit. Didn't it look familiar from yesterday?
Yes.
Ah, how many of you got it? Okay, I'm happy for you. If you haven't got it, don't worry. You'll appear again. I'm pretty sure. I'm pretty sure. Okay? Short circuit effect, exactly true, right? Remember for disjunction, as long as the left-hand side is already true, you don't bother with the right-hand side, right? The left-hand side, obj equals null will just be true, right? Let me make it even closer to your actual lab test. Even closer. Question number 3. Let's say for line number 5, I swap the order so that we do this one first and do this one second. Are we going to get null pointer exception this time? All right? Yes, because we're going to evaluate from left to right. And as soon as you evaluate the left-hand side, which is now this, get class now equal to obj, in this case null, well, you get it right away, right? That will give you null pointer exception. All right. Any question about this? Okay. I think short circuit is very important in programming concept, right? Later on, if you go for a programming interview, that could be a question, right? That could be. Okay, so that's about this class over here. Okay, let me see what's the next. Maybe we want to do some JUnit test. Okay, everything has been discussed. Okay, so that's exactly what we just said. Okay. Okay, there is a principle over here. Okay, basically, when you try to define the equals method for your own class, whenever possible, you should try to reuse the equals method from other class if possible. Okay, we'll see one example when we talk about it. Okay, just keep that in mind. Okay, everything has been said, and now let's talk about collector. Add one extra level of complexity. So now we assume that we have a person class where the equals method has been overridden. That's what we assume. Okay. Now let's talk about the person collector. What is a person collector? Like the point collector. Okay, basically the person collector, let's have a look. Okay, you got person array of persons, right? And then also you got number of persons. And also the add person, person collector, constructor, everything same as before. Okay, nothing surprising. So now let's try to sketch the idea very quickly. You will see that the majority of the code for equals method here will be very similar to the rest, right? The previous example. How would you define the equality between two person collectors? How do you say one person collector is equal to another? Look at this first line as a hint. I said person collectors are equal if they contain equal lists of person. What do I mean by equal list? So that means maybe if one contains 5 persons, the other one should at least contain also 5 persons, not 6, not 4. What's more, if both of them contain 5 persons, the first person should be equal to the first person in the other one. The second person should be equal to the second person in the other one, right? Informally speaking. Can you imagine how we're going to write the code? For loop, I like that. Yes, you're going to need a for loop. Okay, let's have a look. Okay. The loop is not difficult, right? But there's a very important lesson to see from this fragment of code. We'll see that. Okay, we're going to override the equals method in person collector. And don't forget, we have the person class overriding the equals method already. We may or may not want to reuse it. Okay? Okay, up to here, from line number 1 to line number 5, it's just routine. Okay, just routine. Nothing will be changed. Okay? Now, I'll show you the code, okay? The way I define that, let me get you focus over here, okay? So now, starting from line number 6, okay? Starting from line number 6. In line number 6 over here, because we already got other being cast to a person collector, right? That's what we have done, okay? The way I did it is I simply say I have a Boolean attribute, Boolean variable called equal. Okay, initially just false. Okay, and then I will try to do the following. I would say first of all, if the number of persons for the context object person collector is the same as the number of person in the other one, in that case, I will set equal to true for now. If this branch is simply not satisfied, I will simply return false right away, right? Okay, that's some cases over here. And then to run the for loop, I simply say starting from I equal to 0, and then I have a conjunction in the state condition over here. What does that mean? I'm going to stay in the loop as long as they are equal so far. And also, I is still less than the number of persons over there, either way, right? So now, I say that every iteration equal will just be this dot persons I dot equals other persons dot I. Okay? I want you to look at, you can study the code behavior a little bit more carefully yourself and ask me questions, but I do want to point out to you the most important line. Now, look at the pink in line number 10. Which version of the equals method are we calling? Now we got many candidates. We got objects, we got person, we got point v1, we got point v2, we got person collector. Which one? Person? Okay, again, how did you figure? Look at the type of the context object, right? Okay, so now let me just show you again. Basically, what you have over here is, if you look at this is the equals method. What happened before is the context objects over here. Okay, if you look at that, so this over here is a person collector, agree? The current class, right? And then persons will just be an array of person. And now I'm just getting one of them at index I. So that means the context objects of person type. So calling equals is going to call the equals method from the person class. You can see the advantage of this, okay? Let me tell you exactly what I meant. Let's say the following. What if I don't allow you to call the equals method from the person class? How would you write it instead? The question is, I disallowed you to call the equals method from the person class. How would you write it? Just give me some example, yeah.
So we would get the respective values for
Each one of them. Yep, I agree. Very good. Let me write, just write some of them to give you an idea. In that case, you will simply say equal is assigned to, okay, this dot persons I, which is a person, dot name. You know what? Let me just write down in the next page, okay? I want to write it properly. Okay, so now when you review the notes, I want you to look at line number 10 that we're talking about, okay? Line number 10 that we're talking about. The concise version, you simply say this dot persons at position I, which is a person, dot equals. And then we'll say other dot persons at position I. That's the concise version. If I don't allow you to do so, this is what you have to write. You're going to say this dot persons I dot, for example, weights equals what? Other dot persons I dot weights, and also more. That's what you have to write instead. So you can see the value of calling the equals method that's already defined, reusing the code, basically. Okay? So that's a point about doing this in front of you. Okay? The idea about the equals method is every time you want to define the equality for a particular class, think about if its attributes class already got the equals method overridden. If it has, reuse it. If it hasn't, you may have to define from scratch. So that's the point. Okay? Okay, let's go a little bit further. Okay. I have a little bit question for you just about this particular code. Okay? Okay, over here. Actually, what we'll get there when we actually see the code. I think that'll be easier. Now, if I just ask you a little bit too abstract. Okay. So now that's the equals method, and just one more note when you study it. Notice that this equals over here simply is referring to the equals method in the person class. Okay, just notes. Okay, that's why I put it there. Okay, after this, we'll do a little bit more JUnit test. Okay, we'll do the equals method on person collector. Okay, let's go back to the slides a little bit, and then let's see this. Okay, so when you study the slides, it's going to be slide 18 over here. So this is the entire JUnit test. In order to really guide you through carefully, I'm going to divide them into 4 parts. Okay, let's go over each part carefully. Okay, because you might need that for your programming test as well. You might need that. Okay, so let's go over very carefully. Okay, let's not rush too much. Okay, first part. Okay, first part. First part is easy. Okay, so now let's say this. Let's say we got P1, we got P2, we got P3, and also we got P4. First of all, how many new person objects are we going to create? 3 or 4? 3, right? How did you tell? Just count how many new keywords you have. 3, right? Okay, that's exactly 3 over here. Okay, for person 1, it's going to be like this. We'll fill it in very quickly. A, 180, 1.8. And for P2, it's going to be A, 180, 1.8. Notice that they are object equal, but not reference equal, right? And also P3 over here is going to be B, 200 and 2.1. What about P4? Aliasing, right? Oh, I'm pretty sure you're very, very good in this. I'm pretty sure. Okay. Okay, very good. Okay, let's try. First one. What should be, just talk about P1 equals equal to P2. True or false? False, right? Assert false, true, pass. What about P1 dot equals P2? Again, my standard question, which version are you calling? Default or customized? Customized, because over here, you can see P1 over here is the context object, which is of type person. In the person class, we define equals method, right? Okay, that's how you should follow through the logic, right? Very good. And then we know that it's simply just going to compare their measures, right? First name versus first name, last name versus last name, and etc. That's just the same. Okay, so that will be just true. Okay, that was also easy. Okay, another one. What about P3 equals P4? True, right? Because refer to the same object. Very good. Okay. Yeah. All right, final one. What about P3 that equals P4? Okay, so now just for my out of curiosity, since we're comparing, are we comparing references or contents? P3 equals P4. Well, contents, right? Because again, P3 over here is the context object of type person. So again, we're using the equals method. Okay. However, this case, it just happened that they just refer to the same objects. It's a no-brainer because if they refer to the same objects, they should be equal no matter what, right? Okay. So this will also be true. Okay. I'm maybe going a little bit fast over here, but I hope that's okay, right? Okay. Okay. So now let's go a little bit further. Second part, assuming that we got the 4 person objects, right? Assuming that, okay? So now let's continue with that. So now we got to go a little bit more complicated, a little bit more. That's why I'm trying to draw some diagram beforehand. Okay, so now this one just is a warm-up, okay? Now, let's say we got PC1 as a person collector. We also got PC2 as a person collector, okay? It will be very obvious to you, PC1 equals PC2 should be false, right? Obvious, okay? Now, the question is, what happened to PC1 that equals PC2? Before I go over the code with you, why don't you try to see, tell me an answer. PC1 that equals PC2. Well, you can read the code, right? I'll give you 30 seconds. Think about it. How would you trace it? First, can we agree that we're going to call the customized version in point collector, right? Can we agree on that first? Okay. So now we know that PC1 over here is of type person collector. So that means it's now going to call the overridden version. And at this point, after we have created a two-person collector, what should be NOP? 0, right? Just number of person should just be 0. Okay? That'll be enough hints for you. Let's assume we simply create an array of size 100. Okay? You can assume that. So now, if you try to trace the code in the equals method, what would you get? Trace it before I deal with together with you. Would you get true or false? Yeah, let's wait a bit. Yeah. This case is interesting. You're basically comparing two empty person collectors, right? Because the number of person is basically 0 in both cases, right? You want to say something? Please. Yes, you. True or false, first of all? Should that be true or false? Just tell me the answer first. You will say that's false? Okay. Anybody who will say that's true? Okay. Well, one of you should be right? Okay. Let's see this. Conceptually speaking, right? If you got basically two person collectors, both of them simply store no points. It's as if you say empty array versus empty array. They are the same. Okay? That's the answer. Answer should be true. Good. Okay, now, what's more important is which line triggers that, right? Let's try it very quickly. This case is a very special case, okay? First of all, we know that we can reach all the way to the cast, okay, all the way. So now the equal initially is simply just going to be false, okay? So this is simply just PC1. Other is PC2, right? Since we're doing PC1, that equals PC2. Okay, now PC1.NOP equals PC2.NOP. Would that be true or false? True, both zeros, okay? That means we go here and set equal to be true, okay? So now, can you tell me something that should be from back to your 1022? Show me your knowledge, right? Given what we have now, if I try to evaluate this for loop header, what should I get? I give you a little bit hints. Focus on the middle part. The middle part is simply this guy here, right? Okay, equal is true, agree? What about this I less than this .NOP? 0 less than 0, would you agree? Yes, okay, good. That's the beauty about this particular code, because that was simply this condition here. I would just be 0 less than 0, would just give you false, which means you don't get a chance to execute this. That will just handle this case properly. Okay? So now after that, we'll simply return equal, which is being true. So that means automatically these two point collector is just considered as the same, simply because they're both empty. You might write it a slightly different way, but I would say that's one way to write it. But you should know the logic over here, right? At least in my class. Okay? Guys, any question for me for this case over here? Okay? Later on, we're going to see some other cases where the NOP is not actually 0. In that case, you have to run some iteration for the loop. That'll be slightly more complicated, but we'll start with the simple case first. Okay? The lesson from this case over here is you want to know why line number 9, the condition for the loop is initially just false. Okay? That's important. Okay, part 2, I suppose you're fine. Why don't we go to part 3? Okay? Part 3 over here, it's getting more interesting because now we're going to add points to the point collector, right? I already got objects set up for you, okay? Also, I don't need to draw too much. So let's go over the test cases first, okay? So now let's try this. Let's go line by line. First line, PC1.addPerson P1, okay? Assuming that the implementation has been done correctly, okay? Let me just draw carefully over here. Okay, somebody else, that's fine. Okay, good. So now we say that PC1 over here is going to add P1 into it. Now, how would you update the diagram? Interesting. Anyway, yeah, other classroom, I guess. I'm not sure what they're doing, actually. Yeah, physics class? Yeah. I'm sure they will come back, yeah. Anyway, so here, in order for you, oh, actually, this might be a little test for you. If you're hesitant about should you come on Friday or not, if you don't know how to update this diagram here, maybe you should come. Maybe you should. Okay? Well, how do I add P1 over here into this person collector? What does it really mean? That simply means, I'll just mention that. So now I'm going to say position 0, right? Rather than pointing to null, it's now going to point to P1, at the same time update NOP to 1. Okay? That's a correct implementation, we assume. But you should know how to do this in the lab test. Okay? If you're comfortable, no problem. I'm happy for you. All right? So now that's the first one. So now, after this setup, okay, let's try this. What's going to happen if I say PC1 equals PC2? I can tell you that the answer is false. Conceptually, you have PC1 going from non-empty to just one person. PC2 remains to be empty. Of course, they are different. However, exactly how is the code executed, right? That's a problem, right? So now PC1 is a context object, so now we're going to run the overridden version of equals, right? So now let me just point to you very quickly how you're supposed to see it, okay? Very easy. Again, we can go all the way to the cast. And then we're going to set equals to false, okay, the same, okay? And then now, question for you. This .NOP equals other than NOP, would that be true or false? Wouldn't it be false right away? Right? Because you can see the diagram here, if you update it correctly, 1 versus 0, right? False. That would just be false. So that means bypass everything, simply return equal, which was initialized to be false. So that means at this point, if you try to say PC1 equals PC2, it will be false, which is exactly what we are asserting. So it's going to be a pass. Questions about the first one? Okay. What about the next one? The next one, we say PC2.addPerson P2. Okay. PC2.addPerson P2. Okay. Let's see how we can update the diagram again. Updating the diagram is very important. Okay. So PC2, the context objects is this guy here, right? Okay. Let me use green. PC2. How do we add person P2? Okay. P2 is exactly over here, right? We do something very similar. We say that for position 0, rather than pointing to null, it's now going to point to this particular P2 objects, right? Update this to 1. P1 and P2, right? Okay. So what's so good? Okay, let's say that's the setup. Okay. So now, question for you. If I try the following assertions. Number 1, if I try PC1.person 0, PC2.person 0, are they the same objects? You can see from the diagram, no, right? Because one of them, let's try to follow that, PC1.person 0, PC1.person 0 is referring to this object, versus PC2.person 0 that will follow this pointer, different objects, right? So that'll be false. Okay? So assert false will just be okay. Okay? What about next one? Can you try to at least read it, right? PC1.person 0 equals PC2.person 0. Now, which version of equals are we calling? Person collector or person? How do we tell? Context objects, right? That's a keyword. Let's try. You want to see it? I'll show you. PC1 is a person collector. PC1.persons is an array of person. Now you go to a particular position is a person, right? So that means the equals method here is going to be from the person class. Okay? So now basically what this would do over here is PC1 at position 0 is referring to this particular person. Okay? And we are running the equals method on another person. What's another person? Let's try. So that'll be PC2.person0. PC2 is over here. At position 0, we're going to point to this particular person. So we are now comparing basically this person over here and this person over here. Are they equal or not? Okay? You can see quite easily, right? A versus B. Well, you immediately fell. Okay? Easy to tell. Okay? PC1, yep. Okay, good. So they are simply, there may be a typo I made. So I think that should be assert false, right? Okay, what about I simply say PC1 dot equals PC2, right? What we just did in the previous line, we are simply trying to compare two persons, right? But now we are trying to compare two person collector. Now, is it going to give us true or false? Don't worry about the assertion there. I may have made a typo over there, so don't worry, okay? What I'm asking over here is this line. I'll highlight it. Okay, PC1 dot equals PC2. What should that be? Okay, false, very easy, because somehow the previous line already tell you why it should be false, right? I'll point out to you where you should really look at, okay? Let me go slowly with this, because for the rest of the part, I can leave that to you as an exercise, right? Similar reasoning. If you look at this particular one, right? PC1 dot equals PC2. First of all, context object over here is person collector, okay? So we go to the equals method in the person collector. We go there, okay? So now we got PC1 and PC2. And notice that their NOP are the same, okay? So let's go a little bit further. Let me use orange here. So we go all the way to the cast. And equal is also, again, assigned to false initially. And then this NOP equals other than NOP would be true, right? Both 1. And then we set equal to be true. And now, when we evaluate this for loop over here, is this condition now going to evaluate to false? No, because now you can see that different from the previous case. We know that equal over here has been set to true over here already, right? So that's true. And then I is 0 initially. What's this .NOP? 1, thank you. 0 less than 1, true. So that means you will at least go for the first iteration, okay? So now when you go for the first iteration, let me highlight it, okay? The pink one. If you go for the first iteration, you're again basically doing over here, this person's I equals other person's I. Okay, so now you want to know what's this. This is a context object, which is PC1. Okay, so this is PC1. And also what's other? It's basically the PC2 that we talked about, right? Okay, so other over here is PC2. Okay, sorry. I shouldn't say PC1, PC2. I got it. Yeah, actually, that's fine. PC2. Yeah, that's fine. So now, this expression here boils down into this particular expression. Okay? So now, that means PC1, and what's the current value for the loop counter I? It's simply just 0, right? The first iteration. Okay? So now, what you will have to check now will be, again, the first objects over here, and also the first objects over here, and compare them. Are they equal or not? Okay, are you sure? Are you sure? Well, if you're not sure, we should go over again, right? Maybe not, okay? They are not equal because A versus B, right? Okay, not the same, okay? So that means they are not the same. All right. Any question until now? This is tedious, this is tricky, and challenging to trace. I just want to give you an idea how you might trace it by yourself. You might need it later, or in the lab test, or in your labs. Because when things get complicated, especially got collection, you have to know where you are when you trace the objects. I want to give you an idea. Okay? Any question for me? Okay, for the rest, I'll leave that to you to trace. Okay, question? Yeah, so I think I made some typo over there. I'm going to fix it. Okay, so basically, all you can pay attention to are the expressions over here. So if you think about PC1 that equals PC2, over here. So that should give you false because they don't refer to the same person under the hood.
Meaning like the one above, one line above. So it says PC1.persons bracket 0, right?
Yep.
So are we using the equals method from person collector or person?
Okay, your question was, okay, let me write it down over here. Okay, you're basically asking the following. Okay, so this is this line over here. Oh, sorry, the previous line. Okay, we got PC1 dot persons at position 0 dot equals. And then we got PC2 dot persons at position 1. Okay, like that, right? You're asking which version it is being called. Okay, this again, the similar process. Look at what's the context object for equals, right? It will be whatever that happens before. Okay, so this is the context objects. So now what's the type for this context objects? Person or person collector? Well, PC1 itself is a person collector, right? Agree? PC1. And then there is a persons array in the person collector. I don't have it. Oh, yeah. If you go to the previous slide, okay, I'll show you. If you recall, in the person collector class, we have a persons of type array of person, right? Okay. And then over here, let me just go back here. So now that means persons over here is simply persons array. And then I want to go to a particular index of that array. What should that be? A person, right? So everything together over here is going to give me a person. That is why I'm calling the equals method from the person class. Okay, it's good. Yeah, it's good to that you ask. This line is very important because if I give you something like this in the JUnit in the lab test, you should be able to figure out exactly what this is calling, right? Huh? I think for the lab, you can when you study the birthday book tutorial examples, I think we do have to define some equals method. Maybe refer to that example. You will see. Okay. All right. Any questions about this equals method in general? We okay? Well, as I said, equals method is not when you talk about the basic one like a point v1, point v2, they're easy. But once you get to collection, that's actually what you have to do realistically. So that will be more complicated. That's why I spend more time with you on this. Okay. 5 minutes, maybe. Okay. I think we are now done with all the equals method. Okay. Guys, are you sure? No question for me on equals? Are you sure? Yes.
So for all the labs that we have, they always put like add override.
Oh, add override. Okay. So I would say, yeah, what you're asking is, okay, let me switch this. In the lab, what you usually see is add override. And then you declare the Boolean and then equals. And then whatever, right? That's what you're asking, yes. In Eclipse, in order for the tool to actually tell the equals method you are declaring is really overriding it, is overriding the object version, you have to put this tag over here. You just hit the requirements. But I didn't really do this in the class because conceptually you are really overriding the default version. So that's why I didn't mention. Okay? In the lab test, don't worry. In the lab test, I'm going to give you some beginning fragment, give you a template for the equals method. I will include override just in case. Okay. Okay, any other questions about equals? If no, I will suggest we spend about 3 or 4 minutes, okay, to talk about an example for compareTo method, okay? And then I'll finish compareTo and hopefully most of the hash code next time, okay? But let's do it quickly, okay? It wouldn't take long. All right. Let's now talk about this example here. No Java, okay? No Java here. I want to talk about concept, right? Get the concept straight. Can we look at the table over here? Let's say we got 3 employees. We have name, we have ID, we got salary, okay? As you can see, Alan, Mark, and Tom. Alan, Tom has the smallest ID, and Mark are the largest ID, right? And also, if you compare the salary, Alan got a higher salary, whereas Mark and Tom, they have lower salary, but they got equal. Okay? Okay. So now, this over here is just to remind you about the relationship between individual attributes for the person, let's say. You can see the ID, and ID. You can see the ID for Tom is less than the ID for Alan, and also less than the ID for Mark. Agree? Okay, that's what I'm putting here. And similarly, you can see salary for Mark is equal to the salary, I think I meant to say Tom, sorry. Beg your pardon. The salary for Tom over here should be the same as salary for Mark, and also should be less than the salary for Alan, right? That's a relationship. That's what we have. Let's say this, okay, as I show you on the slides. Sometimes you may want to arrange them in a want to sort the employees, maybe for the annual status report for your employees, okay? So now what I will do is I'll show you a little bit slides. Okay, we got the employees over here. The problem, we want to facilitate some annual review on their statuses. So we may have different ways to arrange the employees in the report. Somebody has to come first before somebody else. Okay, that's the idea. Now, let's start with something simple. Let's say we're going to discuss about 2 ways of sorting the employees, 2 different ways. Let's start the easier way. If I want to sort according to their IDs, and here's a rule, smaller ID should come first. In this case, what should be the sorting order? Who should come first? Sorting by ID, and smaller ID should come first. Who should be first? Tom, thank you. Yeah. And then Alan, and then Mark, right? Okay. I want you to notice one thing over here, okay? Conceptually, you want to separate between the order, like a less than, equal, and less than over here. So these are only the relation for their attributes, okay? On the other hand, when we put in the first possible sorting, we put Tom first, Alan then Mark, okay? That means we somehow say Tom is less than Alan, Alan is less than Mark, simply because the ID is in this order, okay? Let me show you another example. What about this guy here? Let's say we want to sort them according to their salaries and IDs. 2 things. However, higher salaries should come first. And if their salaries are the same, smaller ID should come first. That's the rule. According to this, who should be the first? Alan, okay. I agree with you. Because you can see Alan simply got a higher salary, right? Let me put Alan over here. And then, what about next one? How about between Mark and Tom? Mark or Tom? Well, because Mark and Tom got the same salary, right? So you would put Tom first. Okay, let me make a quick remark. Now, this is a different ordering. Conceptually, we say that Alan is less than Tom, Tom is less than Mark. Agree? Conceptually. However, notice that this order over here, Alan followed by Tom followed by Mark, is different from the way you sort the ID. It's also different from the way you sort according to their salary. So somehow you want to combine them in a way. But how do we do that combination? compareTo. Okay, that's what I will do for next week. Okay, before I end the lecture here, let me remind you again. The Friday, I'm going to give the review session on the programming test. It's optional. If you don't feel comfortable about Java, feel free to come.